Okay, so this is day 2 of section 2. Okay, I called it section 2B. We want to be able to write the equation of a parabola in like 2 different scenarios. One scenario, you're told information about the parabola. And then in the other scenario, you're given a picture of a parabola. Could you write the equation? Okay, so you're working backwards from what you did on Thursday. Just real quick review, you probably don't have to write this down, but know that we're going to be looking back at those 2 equations that we wrote down on Thursday. So if you do want to recopy from your Thursday notes into today's notes, you can. When I ask you to write the equation of a parabola in this section, I mean in standard form. So x minus h squared equals 4p times y minus k, or y minus k squared equals 4p times x minus h. Okay, and basically, in order to be able to write the equations, we want to plug in for h, k, and p. Okay, so we need to know what is the vertex. We need to know what is the distance from the vertex to the focus, or the distance from the vertex to the directrix. Okay, so we're going to plug in for those, and always in your final answer, x and y should be variables. So in the final answers, they're going to look at the things that you were working on from Thursday. Okay, we're going to see x and y, but you can tell h, k, and p are numbers. Okay. So that would be what is entailed with writing the equation of a parabola. Here's our first example. We want to write the equation of a parabola with a vertex at the origin and a directrix at x equals 4. And I'm just going to say, jot some of this information down in your notes. My first hint to you, sketch yourself a picture. Okay, so get what visuals you can here. And I'm just going to give you a little bit of time to write and sketch on your own. And you're just going to look at that sketch and think of all the things you know about the parabola. Okay, based on the little bit of information that you're provided. As I walk around, this is the basic sketch that I'm seeing, and that's really all you would do. Maybe now have a quick brainstorm at your tables. Based on that quick drawing or quick sketch, what things do you know now about your parabola? Say as many things as you can.
So you're peeling.
Isn't the P negative, or the focus in negative form?
Yes.
Okay, Joe, tell me something you know.
I know that because the origin is at, because the vertex is at the origin, that it's going to be, that the base for the equation without p is going to be y squared equals 4px.
Oh, okay, so I think you really gave me maybe 2 bits of information here. So you're saying that 0, 0 is the vertex, so that's your h and k, and then x minus 0 and y minus 0 are just really x and y. And you gave me the equation y squared equals 4px. Why did you give me that equation?
Because since the directrix is x equals 4, then it's going to be the y squared equation.
Okay, if you have a vertical line for your directrix, it's going to be a y squared equation. Did anybody else reason that it was y squared for a different reason? Because if you imagine, can your brain fill in where you would draw the parabola here? Okay, it has to be a parabola that opens to the left because it's not allowed to cross the directrix. And so where Joe says because it has a vertical directrix, then it has to be y squared. You could also look at it like, well, I know this parabola opens left, so it has to be y squared. So either way we think about it, we're still getting the same equation. David, did you have another thought? Oh, okay, so you do have the question about the fact that it opens left, so we can infer that it's open left because of where the directrix and the vertex are. And so what has to be negative? P. Okay. So I think that's a really good thing also to think about. If the direction of your graph is opening down or left, then you know that you should have a negative P. Now, Joe only gave me the general equation like y squared equals 4px. Has he told me what p is? No, not yet. So was anybody able to determine the value of p here? Well, the value of p is negative 4, right? P is just the distance from the vertex to the directrix, or the distance from the vertex to the focus. In this graph, we can count the distance to the directrix. So we know the distance to the directrix is 4. Okay, and so we'd be thinking, okay, P is 4, but to go to the right for the directrix, it would really have to be negative 4, or we could think about because it opens left, it has to be negative 4. Okay, so then we know from those two pieces of information that P is negative 4. So yeah, we would go into Joe's and we would plug in the negative 4, which means we do y squared equals 4 times negative 4 times x, which is y squared equals negative 16x. So be really careful there. I heard it when I said, what is P? A few people said negative 16. P is not really negative 16. 4P is negative 16. Okay, yeah, that's in the equation, but if we were to talk about P, it would just be the negative 4 value. Okay with that? Does anybody have any questions or concerns with how we wrote the equation? Okay, I would like you to try another one. Same idea. I'm going to leave it to you to begin. This time, write the equation of a parabola with a vertex at 2, negative 1, and a focus at 2, 1. And you can start with a sketch and start deciding things. Feel free to talk amongst yourselves if you need to confirm your thoughts. Get as far into the equation as you can. What do you think the equation is going to be? Okay, so help me out. Just shout out some things that you know about this parabola.
It's an x squared.
It's an x squared. How do you know that it's an x squared? Okay, the lineup of the focus and the vertex. They're lining up on a vertical line. Remember, the focus is always on the axis of symmetry. So it has a vertical axis of symmetry. It must be opening up or down. Okay, good. What else do you know? Someone besides Jacob, shout some things out. Mitchell,
Directrix can be at y equals -3.
how did you know the directrix would be at y equals -3?
Because the distance between the vertex and focus is 2, so just get down.
Okay, very good. So the distance from the vertex to the focus is 2, so then you should count down 2 to get to the directrix. And you can correctly identify the directrix at y equals -3. Do you really need the directrix to write the equation? No, but Mitchell, what part of that did you just find that you need for your equation? You just found P, okay? Since you counted up to the focus, this is a parabola that opens up, so it should have a positive p-value. So Mitchell just found out that p was equal to 2. Okay, what's the other thing that we need to plug in besides p? H and k, which is provided for us in this one, right? We know the vertex is at 2, -1. Okay, so we can plug that in. So now I think we're ready. X minus 2 squared equals 4 times 2, which is 8. And then y minus -1, which would be y plus 1. And when I say write the equation of the parabola, remember x and y are variables, so leave those alone. You won't actually see your p-value in your final product because you'll have multiplied it by 4. Any questions about that one? So we've got one other example to look at, and it's one where instead of being told information, you get to see the parabola. So I'm going to show you the parabola right here. Oh, and I'll make it bigger so you can see a little better. This is your parabola. Write an equation. So I'm going to give you some time again, jot down what you want in your notebook, and then just looking at that picture, what's everything you know that will be helpful to writing the equation? How far can you get? And if you're getting stuck, think about, why are you stuck? What is it that you need? And think about how you might be able to get it. No. I have given you all the information I want to. You're welcome. Good question, though. Why did you ask me that, David?
Because it looks like a little dotted line in it.
Oh, these are like grid marks.
Oh, okay.
Yeah, they're just the units. Okay.
Oh my God.
But were you looking for something special? You were looking for a directrix. Wouldn't that be nice if I gave that to you? Yeah, that'd be nice because then you could count the distance and find P. Do you know the directrix? No. Do you know the focus? No. So how can we find P? Plug in the point. What point?
We'll use the vertex for H and K, use the other vertex and Y.
Vertex will be H and K. Point 20 will be X and Y. That's all I've given you, isn't it? You don't know where the focus is. You don't know where the directrix is. Which equation should I plug into? The y-squareds. What do you expect about the value of your P? It should be negative because the graph is opening to the left. So let's plug in and see if we get that. Y is 0, minus -1 would be plus 1 squared, and then I would just have 4P times x is 2 minus h, which is 4. That would be 1 squared, which is 1. Careful, that's not 2. 4p times -2, which is really -8p. So p is -1/8. Okay. And did the p value come out like I thought it would, negative? Yeah, is that okay that p is a fraction? Sure, no big deal. Okay, so then to write the equation, remember the equation is not just p equals -1/8. You take your p, you take your h and k, and you plug it back in so that x and y are variables. This time, don't plug in the 2 and the 0. Okay, leave those out. Okay, you only use those to find the equation. So y plus 1 squared equals, and then I would have to do 4 times negative 1/8, which is negative 4/8, which is negative 1/2, times x minus 4. An issue I see popping up is some people just putting their p-value into the equation, like writing it as negative 1/8 times or x minus 4, as opposed to doing 4p. So always remember, when you plug it back into the equation, you still have to multiply by 4. Are we okay with that? Does anybody have any questions? Okay. So think about how you can use what we're doing today to help you with your graphs that you were assigned last Thursday. And when I see you on Thursday this week, I will check both page 700s. We'll go over the answers and questions that you might have. You're also welcome to come see me before or after school if you have any questions.